All right, welcome everyone. Today, we're going to jump right into a concept that is, without a doubt, a cornerstone of modern business strategy: optimization. Now, I want to be clear. This is not just some theoretical exercise. This is the real mathematical framework that lets managers move past just intuition and actually make the most intelligent, data-driven decisions possible. I want you to really think about this question for a moment. What if you could move beyond just making an educated guess? What if you had a rigorous, systematic process to prove that your choices, whether you're talking about managing a supply chain, picking stocks for a portfolio, or launching a marketing campaign, are truly the best possible options you have? That right there is the power and the promise of optimization we're exploring today.
At its heart, every single business, no matter how big or small, is basically an optimization problem. The big question is always, how do we get the most of what we want? Now, that desired outcome, what we call utility, could absolutely be financial profit, but it could just as easily be things like customer satisfaction, making a social impact, or just dominating the market.
And this principle is absolutely universal. I mean, it applies to a giant corporation trying to figure out how to spend a multi-billion-dollar R&D budget, just as much as it applies to a hospital trying to create the most efficient schedule for its nurses to give the best patient care. They all operate under the same fundamental reality: scarcity. You have limited resources, and you have to find the most effective way to use them. That is the universal challenge of management. So here's where our textbook gives us the formal term optimization techniques. And I really want you to pay attention to that phrase, multivariable contexts. Business decisions are almost never about just one thing, right? If you change the price, that affects demand. A change in demand affects how much you need to produce. And that, in turn, impacts your supply chain costs. Optimization is the science of modeling all of these complex, interconnected pieces and finding that one single perfect combination of all those variables to get you to your goal. So let's start treating this like the science it is. We're moving away from some vague goal like, let's improve performance, to a very precise, mathematical way of finding the absolute best result possible. Okay, this is our formal definition, and every single word in it matters. It's a mathematical process. That means it's objective, you can repeat it, and you can verify it. It's not a gut feeling. We're finding the best possible outcome, the absolute peak or the absolute valley of a function. And maybe most importantly, we're doing this within a set of real-world limitations. These aren't just little annoyances. They are the rules of the game that define the entire problem. Now, here's the good news. Any optimization problem, and I don't care how ridiculously complex it seems, can be broken down into two fundamental components. If you can really get a handle on these two ideas, you'll have the framework to tackle any optimization challenge you'll ever face. So let's start with the first piece of the puzzle, the objective function. This is where we lay out our ambition. It's the what of the problem. Before we can find the best answer, we have to be crystal clear about what we're actually trying to do. So think of the objective function as the mathematical translation of your business goal. A vague idea like, let's increase profits, is useless here. We have to be precise. Are we trying to maximize gross profit, net profit? What about minimizing costs? Are we talking production costs, shipping costs? This equation becomes our North Star for the whole process. It's the number we're trying to make as big or as small as possible. Let's make this real with a simple bakery example. Let's say our objective is to maximize total profit. The function you see here is a pretty good start. To get even more realistic, you'd probably have something like total profit equals the price of a cake minus the cost of a cake times the number of cakes we sell, plus the price of a cookie minus the cost of a cookie times the number of cookies we sell. In this case, the number of cakes and number of cookies are what we call our decision variables. They're the knobs we can turn to try and find the highest possible profit. But of course, our bakery doesn't operate in a magical world where it can just bake an infinite number of cakes. And that brings us to the second and equally important component of any optimization problem. This is where the real world kicks in. Constraints are, simply put, the rules of the game. They are the non-negotiable limits that draw the map of what's actually possible for our business. I like to think of them as the walls of a maze. Our goal is to find the best possible spot to stand, but we have to stay inside those walls.
And here are some of the most common constraints you'll run into. The textbook points out budget limits and production capacities, and those are huge. But you can also have limits on how much the market actually wants to buy. You can have logistical constraints, like how much you can fit in your warehouse. And of course, you have labor constraints. You only have so many people working so many hours. A really good optimization analysis means finding every single one of these. Let's go back to our bakery and put some numbers on this. Let's say our weekly budget for ingredients is $500. Well, we could write that out as a mathematical rule. The cost of ingredients for our cakes plus the cost of ingredients for our cookies has to be less than or equal to 500. And what about the oven? If it can only run for 10 hours a day and a cake takes 1 hour, while a batch of cookies takes half an hour, we'd have another rule. 1 times the number of cakes plus zero point 0.5 times the number of cookie batches has to be less than or equal to 10. Our final decision about how much to bake has to follow both of those rules. Okay, so we have our two fundamental pieces of the puzzle. We have our objective, that's what we want, and we have our constraints, that's our reality. The real magic of optimization happens when we see how these two things push and pull against each other. This slide really shows that core tension perfectly. On one side, you've got your ambition, that objective function you're trying to push as high or as low as it can go. And on the other side, you've got the hard reality of your constraints pulling you back. The entire process of optimization is just a systematic hunt for that perfect sweet spot, the optimal feasible solution, where we get the best possible result for our objective without breaking any of our rules. This right here is the critical takeaway for today. The best answer has to do two things at once. First, it has to be the absolute best value you can get for your objective function. And second, it has to be feasible, which is just a fancy way of saying it doesn't violate a single one of your constraints. You can have a solution that's feasible but not the best, or one that would be the best but isn't feasible. The true solution has to be both. And this brings me to the single biggest mistake I see students and, frankly, real-world businesses make. It is so easy to fall in love with your objective function. A marketing team might dream up a plan that promises huge profits, but if that plan requires you to make more stuff than your factory can possibly handle, it's not a plan, it's a fantasy. A solution that isn't feasible isn't a solution at all. It's a critical error. So here is your playbook for any optimization problem you encounter. Step 1, you have to translate your business goal into a precise mathematical objective function. Step 2, you have to hunt down every single real-world limitation and write it down as a mathematical constraint. And finally, step 3, and this is where the more advanced math kicks in, you use techniques like linear programming to solve the whole system and find that one single, optimal, and feasible solution. I really cannot overstate how important this framework is. This is not just some abstract idea for a math class. This exact 3-step process is the foundation for how huge decisions are made in every part of a business. Airlines use it to optimize their flight schedules, investment banks use it to build perfect portfolios, logistics companies use it to design the most efficient supply chains. Getting a handle on this way of thinking isn't just about this course. It's fundamental to having a successful career in business today. So, I'm going to leave you with a question to chew on as you continue your studies. When you're out there in your future career, what's going to be the single most important thing your company should be optimizing for? Is it going to be quarterly profit, long-term growth, customer happiness, employee retention? And more importantly, how are you going to deal with the fact that sometimes trying to maximize one of those things means you have to sacrifice another? Start thinking about that now, because that is the central challenge of being a strategic leader.